Hello students, welcome to my channel Sri Ram Edu Talks. In today's class, we are going to learn the laws of exponents. So let's start the class by first of all understanding the meaning of exponents. So we suppose have a number a which is multiplied by itself n times, then I can write this in the form of exponents as a की power n. Here, a is called the base, whereas n is called the exponent. For example, if I multiply 5 by itself 4 times, then I can write this in the form of exponents as 5 की power 4. Okay, now let's start with the laws. Actually, exponents follow certain rules that help in simplifying expressions. So these rules are actually called the laws of exponents. So our first law is any number raised to the power 0 is always 1. For example, if I have 2 to the power 0, then I can write it to be 1. Or if I have minus 2 की power 0, then also it's 1. Even if I have a fraction to the power 0, then also the value comes out to be 1. Okay, let's move on to the next law. If we have a to the power m multiplied by a to the power n, that means we have base same over here, whereas the powers are different. Then in case of multiply, if we want to combine these two as a single base, then the powers get added. For example, 2 to the power 3 into 2 to the power 4, here the base are same and they are getting multiplied. So I can write this as 2 to the power 3 plus 4, which is 2 to the power 7. Right. Then our third law is the same way if I have bases same but are getting divided, then if I have to combine them into a single base, the powers get subtracted. The first power minus the second power. For example, let us take 2 to the power 4 divided by 2 to the power 3. I can write it as a single base as 2 की power 4 minus 3, which is 2 to the power 1. Okay, let's move on to the fourth law. Fourth law is a to the power m whole to the power n. That means one power is inside and one outside. These two powers will get multiplied with each other. Also, in case if we have an expression like this, that means I have three powers now. So this also can be written as a की power m into n into p. And this rule can be extended further as well. For example, 2 to the power 3 to the power 4 becomes 2 to the power 3 into 4, 2 to the power 12. And likewise, if I have one more power outside, then collectively I can write this as 2 to the power 3 into 4 into 5. That is 2 to the power 60. Now, let's move to the next fifth law. Now, I am going to change the base. As you can see, now in these two, the bases are different, but the powers are same. If I have to combine these two, I will combine the bases in a single bracket raised to the power that same power n. For example, if I have 2 to the power 3 into 5 to the power 3, I can combine them in a single bracket as 2 into 5 whole to the power 3, which is 10 to the power 3. Likewise, in the next law, in place of multiply, if I have divide, then also I can combine them in a single bracket raised to the same power n. For example, 2 to the power 3 divided by 3 to the power 3 can be written as 2 divided by 3 to the power 3. You can further write it as a fraction, as the case may be. Now, our next law is quite simple. Any number raised to the power 1 is always the same number. Now, this number can be negative number, can be positive number, can be fraction as well. And it can be fraction as well. Quite simple. Okay, let's move forward. Our eighth law now introduces the negative power. Any base raised to the negative power, normally it cannot be solved. We cannot solve it directly. Like if I have 2 to the power minus 3, I cannot expand it. So first I need to convert the negative power into positive. And this rule says if you have a negative power, just reciprocate the base and the power will get positive. For example, 2 to the power minus 3 will become 1 upon 2 to the power 3. And then you can solve it further. Likewise, the next law says if you have a fraction raised to the power a negative quantity, then also I cannot expand it. So if you reciprocate it, just do a reciprocal of the base, which is a fraction, and the power will get positive. For example, if you have 2 by 3 raised to the power minus 2, you can't solve it as it is. You will have to reciprocate the base, which is a fraction, and the power gets positive. Now this means 3 multiplied twice in the numerator, 2 multiplied twice in the denominator, 9 by 4. Okay. The next law is now regarding root signs, square root, cube root, fourth root, and so on. It says that if we have nth root of any number and I want it to be in the form of exponents, that means I want to get rid of this root sign, I will simply raise the base, which is a, to the power 1 upon n. For example, if I have square root of 5, now we all know that we don't write a 2 here. It is understood that if nothing is written, it is square root. So I can write in the form of exponent as 5 to the power 1 by 2. Likewise, if I have cube root of 5, I can write it in the form of exponent as 5 to the power 1 by 3, and so on. Okay. My next law says that if we have nth root of a whole to the power n, you see, the same number is the power which is the root here. Then these two cancel each other, which means now a will come out of this square root sign. Let's take an example. If I have square root of some number and the same is in the power, then this square root sign and the square cancel out each other by removing this root sign. Let's take one more example. If I have cube root of 5 raised to the power 3, then also these two numbers, as long as they are same, the number will come out of the root sign. Simple. Next, rule number 12. It says that if we have x to the power a is equal to x to the power b. So in many such problems, we come across a situation where we have an equality. Both sides, the bases are same. I can say that in this case, if the bases are same and they are equal, then the power also has to be same. For example, if I have 5 to the power x equal to 5 to the power 2, I can say that the bases are same, so are the power. That means x की वैल्यू हो गई 2, x is equal to 2. Okay. Lastly, rule number 13. It says that now instead of bases being same, if the powers are same on both sides of the equality sign, that is, if x to the power a is equal to y to the power a, the powers are same, bases are different. Then also, this time power same, base different, so I can even say bases also has to be same. X is equal to y. Let's take an example. So if I have x to the power 3 is equal to y to the power also 3. As you can see, both sides, the exponent or the power is same, but the bases are different. I can say that these two quantity x and y also has to be same. So students, I hope you must have enjoyed and learned a lot in today's class. Now, for more such videos, I request you to please subscribe to my channel, and also don't forget to press the bell icon to never miss an update from Sriram EduTalks. Thank you.